Hello, my name is Laura Modelli and welcome to Science for Education, supporting teaching and learning in science education. In this video, we are going to discuss electric circuits and electric current. And in today's episode, I'm going to be using the electricity and magnetism kit from UDOX. Have you ever wondered how the light in your bedroom works? Or perhaps you've received a Christmas card that lights up? Or a birthday card that has music playing when you open it. Or maybe you have wondered how a flashlight works. In this video, we are going to learn the very basic principles of electric circuits and electric current that electrical engineers use to turn on lights in your house and that companies use to make fancy cards that light up or have music in them. Here, I have several materials such as a battery and the holder, a light bulb and the holder, a breaker, or commonly known as a switch, and some wires. To turn on the light bulb, you will need a source of electricity. Before we continue, first I want you to understand where the electricity is coming from in this activity. Our electricity is coming from the battery. The battery uses energy from chemical reactions to separate positive and negative charges within the battery. How is the work done? The chemical reaction process produces an increase in electrostatic potential energy of the charges, which leads to a voltage difference. In other words, the chemical reaction generates a potential difference between terminals, meaning there is an excess of positive charge at one end and an excess of negative charge at the other. Now these charges will tend to rejoin by flowing from one terminal to the other, but only by an external conducting path. For example, if you connect a metal wire to the two terminals, charge will flow through the wire to the opposite terminal. This flow of electric charge is what we call electric current. And the direction of the electric current is in the opposite direction to the motion of the electrons or negative charges. To be more precise about the definition of current, current is the rate of flow. Current is the amount of charge that flows per second and can be written mathematically as I equals Q over T. In science, we use symbols to represent certain things. So here, electric current is symbolized as I, Q is the charge, and T is time. Next, what happens if we make a path for the electric charge to flow between the two terminals by using some wires and passing through a light bulb? The bulb will light up. This path that we just made is called a circuit or closed loop. Here we have a breaker, commonly known as a switch. We use this breaker or switch as a tool to connect and disconnect the path. When we use the breaker to disconnect the path, we create something called an incomplete or open circuit. The current cannot flow to the other terminal through the bulb, and the light is now off. This simple concept is how the lights in your house work. The power company generates electricity using water, nuclear, gas, wind, or coal, and sends it over power lines to your house. The electricity comes into your house from the power lines, and when you turn on the light switch, it completes a circuit, and your lights turn on. You might be thinking, if the light switch breaks the circuit, why did the lights still work in another room? We'll discuss this in another video about parallel and series circuits. Thank you for watching this video. I hope you guys have enjoyed watching and learning about electric circuits and electric current. If you did, click the link below for activities that you can do yourself. See you next time.